In this lesson, we're learning about systems of linear equations. A system means we have two equations that talk about the same x and y values. The solution to a system is the point that makes both equations true at the same time. When we solve a system by graphing, we graph both equations as lines. Wherever the two lines cross, that point is the solution. Think of it like this: two lines on one graph. The place where they intersect or cross is the answer. Here's our example. We're given two equations, y equals x plus 1 and y equals negative x plus 5. We graph each equation as its own line on the same graph. Once both lines are drawn, we look for the point where they meet. The two lines cross at the point 2, 3. That means when x is 2, y is 3, and both equations are true. So the solution to this system is 2, 3. When you solve a system by graphing, remember, graph both lines, find where they intersect, and read the point. That intersection is always the solution. The substitution method is used to solve a system of equations. Substitution means replace one variable with what it equals. First, look for an equation that is already solved for one variable. Here, y equals x plus 1 is already solved for y, so we use that one. Now we take x plus 1 and replace y in the other equation. Wherever you see y, you plug in x plus 1 instead. Now the equation has only x terms. Combine like terms to make it simpler. Solve the equation to find the value of x. Here we get x equals 2. Now we plug x equals 2 back into the equation y equals x plus 1. We can also plug it back into the second equation, it doesn't matter. That gives us y equals 3. The solution to the system is the ordered pair 2, 3. This point makes both equations true. This example will show the process clearly from start to finish. Pay attention to the written explanations as each step appears on the screen. If you can substitute correctly and solve carefully, the system will always lead to one solution. In this lesson, we're using the elimination method to solve a system of equations. The big idea is simple. We want to make one variable disappear so we can solve for the other one. Take a look at these two equations. Our goal is to eliminate one variable, and right away we see something helpful. One equation has plus y and the other has minus y. Those are opposites. That means if we add the equations straight down, the I values will cancel out. When we add them, y disappears, and we're left with 2x equals 14. Now we solve like normal. Divide both sides by 2, and we get x equals 7. Now that we know x, we go back to one of the original equations. We choose the easier one. X plus y equals 10. We plug in 7 for x, which gives us 7 plus y equals 10. Subtract 7 from both sides, and we get y equals 3. So the solution to the system is 7, 3. Here's an example that shows how this concept works in practice. Follow along by reading the explanations and watching how each step is done. The elimination method works best when variables are opposites. Add or subtract to make one variable disappear, solve, then plug back in.